Hey, Trig kids. Today we're looking at section 6.3, more solving equations with trig functions. Notes out and away we go. All right, so we're looking at more of the same. We're going to look at more kind of tricks, tips, and techniques to solve trig equations. In this section, we're going to discuss trigonometric equations that involve functions of half angles and multiple angles. So we need to figure out a way to take care of the half angles and the double angles that show up in problems. Solving these equations often requires adjusting solution intervals to fit given domains. And we'll talk about that as we go through the problem. For example, let's solve this equation. 2 cosine of x over 2 minus root 2 equals 0. So we can see this is a half angle trig function. And so we're going to solve this over the interval 0 to x to 2 pi. And then another way to think about this is because we're doing a half angle, we're going to take half of our regular interval. So we're actually solving this over 0 less than x halves less than half of 2 pi, which is pi. So we're actually looking for solutions then that fit between 0 and pi. So let's solve. So we're going to solve this just like we did in the last video. We're going to add the root 2. So 2 cosine x halves equals root 2. And we're going to divide both sides by 2. So cosine then of x halves is equal root 2 over 2. This is positive. So when we consider cosine we remember is positive, negative, negative, positive. So that means we're looking for solutions in the first quadrant and the fourth quadrant. We want to figure out then what is this angle. So what's the angle for cosine that'll give us root 2 over 2? Well, that is 45 degrees, but we are in radians, not degrees. So that is pi force. So over the interval 0 to 2 pi, we're actually considering the interval 0 to x halves to pi. And so then our angle then is pi halves. So the angle that gives us root 2 over 2, our reference angle theta, then is pi force, right? Because the cosine of 45 is root 2 over 2. So what are we going to do with that? Well, we know our angle is x over 2, and that's going to equal 2 pi force, and that's in quadrant 1. In quadrant 4, then we're going to have 2 pi minus pi force, which is 7 pi force. That's also going to equal our angle, x halves. But we want to solve for x, not just x halves. So the easy way to do that is to multiply both sides by 2. Therefore, x has to equal double pi force, which is 2 pi force, which is pi halves. And x equals double 7 pi force, which is 7 pi halves. But then when we go back and check our interval, we're only looking for solutions that are between 0 and pi. Therefore, pi halves is our only solution, not 7 pi halves. That's not in the interval. So there's our solutions from the interval 0 to 2 pi. Then we want to give all solutions. To find all of the solutions, we have to consider our period. Remember, our period is 2 pi over b. So that's 2 pi. Well, our b number is now 1/2, and that comes from our equation. So the b number is the 1/2. So that means our period is now 4 pi. Another way to think about that is if we would have taken x over 2 equal to our regular period, 2 pi, and we multiply by 2, that means our x has to have a period of 4 pi. So to get all solutions then are going to be our pi halves. But instead of adding 2 pi in, our period changed, so we're going to add 4 pi in. Is one solution. Our other solution is the solution that originally wasn't in the interval, but will be for all solutions. So that's 7 pi halves plus 4 pi n. Again, where n is any integer. So there's our two solutions. Example 2, we're going to solve then a double angle. So cosine of 2x equals sine x over the interval 0 to 2 pi. So we don't want a double angle, so we're going to check our pink sheet identity and see what we have going on. If we check there, we're going to see there's actually a sine version. So we're going to replace the cosine of 2x with an identity. Remember, you can't just divide both sides by 2 because this is in the argument. So we're going to replace this with our double angle cosine identity that has a sine in it. That's going to be 1 minus 2 sine squared x is equal to sine of x. From there, we can set it equal to 0. So we're going to subtract or add the 2 sine squared x over, subtract the 1. So 0 is equal to 2 sine squared x plus sine of x minus 1. That's a quadratic, so we're going to factor it. Again, if you struggle, turn it into a regular quadratic, 2x squared plus x minus 1, and factor that to factor the trig function. Signs are different. Multiplies give 2x squared, has to be 2x and x, and 1 and 1. We'll check it. That's a negative 2 plus 1. We need a positive, so I need to change my signs. So there's my model. So I'm going to have and I did that a different way. So we're going to do this a couple different ways. So that gives us, hang on a second. Yes, so that gives us, when we go back and factor this, 2 sine of x minus 1, using this as my model. We're going to replace the x with sine of x, and then a sine of x plus 1. That equals 0. So again, that takes us to our 0 product rule. 2 sine of x minus 1 equals 0. Sine of x plus 1 equals 0. Therefore, sine of x has to equal 1/2. Sine of x is equal to negative 1. Okay, from there, then we're going to get our values. So we have a sine of 1/2. So for sine, we're going to remember that sine is positive, positive, negative, negative. So that means we're in the first and second quadrant. So in the first quadrant, the sine of 1/2 gives us the value of sine of 1/2. Well, that's sine of, in radians, that would be 30, but in radians, that is pi 6. So x is pi 6. In the second quadrant, our reference angle is pi 6. We want pi 6 in the second quadrant, which is pi minus pi 6, which is 5 pi 6. And then we have a quadrantal angle where sine negative 1. Again, for that, we can think about the sine graph. Starts at 0, goes to 1, 0, negative 1, 0. So where is sine negative 1? That's at, here's pi. So that is at 3 pi halves. That only happens at one place. So therefore, our solutions are pi 6, 5 pi 6, and 3 pi halves. So again, another approach is to take a double angle identity and swap it out, and then solve using algebra methods. Example 3, we're going to solve over the interval 0 to 360. So now we're back to degrees. We have 2 cosine squared theta minus 2 sine squared theta plus 1. Now, looking at these, there may be other identities you see that might be a little bit more useful or different ways to do this, and that's fine. You should still get the same answer. But we need to look at this and recognize we have a cosine squared and a sine squared, and we want to eliminate one of those so we can solve. But we know that sine squared plus cosine squared is equal to 1. So we're going to set cosine squared of theta is equal to 1 minus sine squared of theta. So we're going to, again, use an identity to get rid of cosines so we can combine all the sines and then solve. So this is going to be 2 times 1 minus sine squared theta minus 2 sine squared theta plus 1 is equal to 0. We'll run this through distributive property. So that's 2 minus 2 sine squared theta minus 2 sine squared theta plus 1 is equal to 0. That's going to give us a 2 plus 1 is 3 minus 4 sine squared theta. Those are the same, so we can combine my terms. Now we want to solve for sine squared of theta, so we're going to subtract 3, divide by negative 4, so sine squared theta is equal to 3/4. We can undo the squared then by square rooting. We get sine squared, not squared, sine of theta, then is equal, because we square rooted to solve, it's a plus minus √3/2. So there's our sine equation value. For sine, we're going to remember that sine is plus, plus, minus, minus. But here we have both a positive version and a negative version. That means we're going to want answers in all 4 quadrants. Next is we need to find our reference angle. So what is the angle that gives us √3/2 for sine? In the first quadrant, that angle is 60 degrees. So our reference angle is 60 degrees, again, because we are in degrees by the interval in the problem. Therefore, we're going to need 4 answers, 1 for each quadrant with 60 degrees. In the first quadrant, our angle is simply the reference angle, that is 60 degrees. In the second quadrant, that's 180 minus 60, which is 120 degrees. In the third quadrant, that is 180 plus 60, that is 240. And in the fourth quadrant, that's 360 minus 60, which is 300 degrees. Again, you can check all of those answers by plugging back into the original equation, making sure your calculator's in degrees. Example 4, solve over the interval 0 to 2 pi, cotangent of 2x minus cosecant of 2x. So here we have double angles. So one thing you might do would be to look and see if there's an identity for cotangent of 2x and cosecant of 2x, but there's not, because they're sine, cosine, and tangent. So another option is to switch these so that they are cosine, sine, and tangent. And to do that, we're going to recognize that cotangent is the identity cosine over sine. So this becomes cosine of 2x over sine of 2x minus cosecant of 2x is 1 over the sine of 2x. Remember, the arguments just say the same. Well, from there, we can see that they have the same denominator. So because they have the same denominator, we can combine to get like terms. And so that's going to get us cosine of 2x minus 1 over sine of 2x equals 1. Now we have our double angle identities in terms of sine and cosine. So now we can plug in our double angle identities. For cosine of 2x, we're going to look up that identity. That is, again, 1 minus 2 sine squared of x minus 1. For sine of 2x, that's 2 sine of x cosine of x, and that still equals 1. From there, what can we do? Well, 1 minus 1 is going to cancel. It's still a negative 2. So those are gone. Now the 2's can cancel because there's no other added subtracted terms. Now, one of the signs can cancel. So that sign cancels with one of the signs. We're left with a negative sine of x over cosine of x equals 1. Well, negative sine x over cosine x, that's negative tangent of x is equal to 1. Therefore, tangent of x is equal to negative 1. So now we're considering tangent on the interval from 0 to 2 pi. Tangent, we recall, is positive, negative, positive, negative. Because we have a negative 1, that means we're in the first and third quadrants. We need a reference angle. So what's the angle measure that will give us a tangent of that angle measure to get us 1? Well, that's 45, but we're in radians. So that is in radians pi fourths. And we want the answer in the first quadrant. No, we don't. We want a negative number, not positives. We want negative answers. So we want answers that are in the second quadrant and the fourth quadrant. Therefore, X has to be in the second quadrant, pi minus pi fourths, which is 3 pi fourths. And then the fourth quadrant, 2 pi minus pi fourths, which is 7 pi fourths. That wraps up section 6.3. Our homework is 282, problems 8 through 42 even. Have a good day, Maroons.